Hello, so we are back, and this time we have a laptop. Yeah, usually the laptops are nice laptops, but this one is insane. I mean, not only is very expensive, but has some nice specs. This is a ASUS ZenBook. I believe the screen is OLED. ZenBook UX363E, I believe. The problem with this one is not coming on. So this is really, really a nice laptop, nice and expensive. So pressing the power button and nothing happened. Let's plug a charger and see what it's doing. So plug in the charger with the power meter, and the power meter is coming on and is negotiating the voltage, but all what is taking is around 20 milliamps, you can see. Pressing the power button, nothing happened. I mean, the current doesn't go up. So that's what we have to fix today. Okay, let's open this one. This laptop is coming from, I don't know if it's a computer shop or it's just a guy who's fixing laptops. But let's do someone check the laptop. So let's open the laptop and see what we have inside. Okay, so the laptop is open. That's a nice motherboard. So what do we have here? The SSD is missing. We have the IT chip, you can see. The EC chip. Can you spot anything unusual on this motherboard? Huh? The customer said no one tried to perform repairs on this motherboard. Because usually if they are saying, okay, someone tried, there's no point. You know what I mean? Usually I don't take that kind of jobs. So plug in the charger. What we are checking first? First, we are checking the main power rail to see if it's present. Yeah. So the PD controller, not sure it is this one, it is negotiating the voltage. So the main power rail is 0. So you see, in this case, the main power rail is not present for some reason. I mean, it is 0, right? So my multimeter is good. Okay, it is 0. So why the main power rail is 0? That's a good question. Let's unplug the battery and let's check the main power rail to the ground, yeah? So main power rail to the ground, 1 ohm. So what do you think? It has 1 ohm. So if my multimeter has 1.2 ohms and this has 1.2 ohms, it's a very high probability actually here to be a capacitor. I mean, we have like 0 ohms. Or let's check the CPU. If the CPU has 1 ohm, it's clear. So the CPU, 70. Here we have 70, 170, 170. I'm checking the coils in case you have this laptop to know the resistance on the coils. Nothing. 37. Nothing. You see on you have no idea, or maybe you have an idea how helpful it is. Okay, I have a dead laptop, everything is good, but it's not working. But just, based on the fact, yeah, you can see the resistance. Oh, sorry, checked, and the resistance on the CPU should be 70 ohms. Okay, so if I don't have 70, I know it's at the CPU. I mean, the CPU doesn't mean 0 ohms. The CPU is meaning instead of 70, I have 60. You know what I mean? So it's very helpful, to get readings. And I'll try to get readings from every laptop I check. Okay, great. Let's grab the power supply like usual. This seems to be an easy and pleasant job. Living on one side, this laptop is very expensive. So let's grab the thermal camera. And we're going to try to push some current I don't believe it's a MOSFET, yeah, because we checked the resistance on the coils already. How much current we have? 10. No, we need more. Let's raise the current to like 2 amps. Yeah, 2 amps. Yeah, that should be fine. So with 2 amps, here we have 0.2, and here we have 0.2. Lol, I can't even figure it out which is plus and which is ground. Let's raise the current to 3.5 amps. So this one has 0.4 and this one has 0.3. Okay, so now I know for sure the plus is here. So the plus is here. What is getting hot? Huh? What is that? What is that? So where it is? Here. Oh lol. Okay, those are good news. Yeah, very possible we can fix this laptop and we can make the customer happy regarding this repair. So on the microscope we have, oh lol, it's not even point checking. I mean, check that. It's even point trying to figure it out which capacitor is that. And you can clearly see this is blow up, this capacitor. So let's remove this capacitor quickly. So the capacitor is removed. This is a lucky customer. He doesn't get the capacitor back. I mean, we still have one there. We see we have a bunch of capacitor. I mean, this customer has so many capacitor. Okay, so everything looks good. Let's cool down the motherboard. Hopefully it will work. Cooling down the motherboard. Good. Plug in the battery. We plug the battery. Let's plug the charger. Plug in the charger. It's charging 1.2 amps, 2 amps. Check that, 2.1 amps. You can believe that? And we have the charging light here. Check that. We have the charging light. And the laptop is on because probably we removed the battery when we reset the BIOS and we have picture. I can't believe. It's working. This is a lucky customer. I checked on the internet. It's like £1,000, this laptop. It's very expensive. Unplugging the charger. Yeah, the battery is holding the charge. Everything is fine. This is a very lucky customer. Yeah. Okay, let me switch off. Wow. Exactly 10 minutes is shown on the OBS. Okay, so looks like the problem on those days are still the capacitors. Now, why the capacitor getting shorted? From a simple reason. In order to achieve high capacity, yeah, on the capacitor, is a multi-layer capacitor. You have to go down on the voltage. Yeah, so you go down on the voltage and you can increase the capacity on the same size. So when something goes wrong, you know, they go shorted. You have layers. You have, you know, it's like fingers. So inside of the capacitor is like that. Yeah, so you have one terminal and one terminal, and that's how the capacitor are made. And you know what I mean? Going low on the voltage does mean the distance between the plates goes smaller and smaller and smaller. And yeah, at some point they are dying. Good? Perfect. Finally, I fixed something today. I'm gonna stop now. I will say thank you for watching. Like and subscribe if you like the video like usual. And see you on the next one. Bye.